which is just like a short answer version of the exam. The problems will be different than the ones that will be on the test, but it'd be very similar stuff. So I send out a review every week before an exam. So that gives you something to go by, some practice problems. So if you're doing the canvases and doing well on those, and then you do that review, you should be able to come in here next week. We'll do the labs, and then we'll do the test, and you should do well if you prepare. And that also gives you a place that you can find some questions to ask if you need to. So we're going to start with section R2 in your book, talking about absolute value. Absolute value is what? Does anybody know? From where? Nope. 0. Distance from 0. So absolute value is a distance from 0. We're going to put x's in there, so we're looking for a distance away from 0 that is x out of that. But the whole idea of distance is you go to Lowe's, you go to Ace Hardware up here in town, you buy a tape measure. What kind of numbers are on that tape measure? And what kind of numbers are not on that tape measure? There's only positive numbers on there. So when you go to measure something, a distance is only going to be positive. So when we're dealing with absolute value, the absolute value of 3 is what? 3. But at the same time, the absolute value of -3 is 3. Because those are the same distance away from 0 on the number line. They have that same value in absolute value. When it comes to order of operations, absolute value equates to a grouping symbol. So it's like parentheses. So parentheses, exponents. So when you see an absolute value in a problem and it's asking you to evaluate that, it's going to rank, absolute value ranks the same as parentheses. So when you see a problem, something like this, maybe -1, absolute value of 5 minus 6 plus 3, something like that, kind of puts it all together. And I'll try to color in my ones and my absolute values. So again, it ranks the same as a parenthesis out of that. So we're going to do the parentheses first, or the absolute value first. So it'd be -1 inside of there. So the absolute value of -1 is +1, and -1 times 1 is -1 plus 3 is 2. So absolute value mixed in there. Follows the order of operations stuff. Nothing too major about that. Let's look at an evaluation problem like we were talking about. To ask you to evaluate for x equals -6 and y equals 10. So it gives you some variable values. Example D. Let's do absolute value of 2x minus 3y. Working that out. Plugging in those values. And then finding the absolute value of that result. So the absolute value of -12 minus 30, which is -42. And the absolute value of -42 is +42, because it's 42 jumps or hops or whatever it was that when you first learned that in elementary school about absolute value. I don't know if y'all remember. I had a teacher. She was just so nice. We had a number line that she had like up on top of her board, and she had a little bunny rabbit, and she would hop it down the number line to explain things, and it worked. It ended up making me a pretty decent math student. So, but I don't have bunny rabbits on my board at school. Maybe I should, but I don't. Absolute value, or 2 times the absolute value of x minus absolute value of 3y all of that divided by the absolute value of x, y. So a little bit more complicated one, but still, it's just order of operations. We know that the inside of the absolute value has to happen first, and then we follow the old steps from there. So it's going to be 2 times absolute value of -6 minus absolute value of 3 times 10 over absolute value of -6 times 10. Let's try to darken in my absolute value mark. So that'd be 12 minus 30 over 60. Be -18 over 60. And just reduce that fraction. -3/10. All right, so order of operations, all that fun work there. We could end up with negative answer, but it doesn't. It's not because of the absolute values in the problem. It's just because of the way it worked out. Section 1 done. It is that simple stuff. The R2, their R section, remember, it's just a review of basic things. So let's get to the more difficult stuff. Section 1.8. So this is chapter 1 out of the textbook. Toward the end of that chapter, absolute value equations and inequalities. So when we talk about absolute value, what is it again? It's the distance away from zero. So when we're dealing with an equation, we'll start with something as simple as I can make it. The absolute value of some number, x, is equal to 6. Well, what numbers are 6 units away from 0? 6 and -6. So what that means is we set up these two equations, x equals +6, x equals -6. Whatever's inside of the absolute value, we're going to set equal to the positive side and to the negative side, because that's the that absolute value is the distance. So whatever's inside of it represents that distance. So when we go to one that's a little bit bigger, but still pretty easy, absolute value of x plus 3 is equal to 6. What are the two equations that I'm going to set up? X plus 3 equals -6, and x plus 3 equals +6. Set up, take the absolute values off, set up one equal to the positive side, one equal to the negative side. We're going to solve it. We'll get two answers out of that. So get x by itself on each of those problems. Be -9 and +3. If you plug each of those back into the problem, I plug -9 in here. -9 plus 3 is -6. We know the absolute value of -6 is 6, so that will check. It works. Plug 3 in here. 3 plus 3 is 6. The absolute value of 6 is 6. So both of those are valid solutions for that. So absolute value's got to be by itself, and then we set it equal to the positive and the negative if it's equal to a positive. Because remember, distance can only be positive. So when we're dealing with absolute value, the one that's a little bit more difficult, it's got to be equal to a positive number. So this one is equal to a positive number. So its absolute value of something is equal to 10. So that means that something has a distance of 10. So that something could be sitting at -10, or it could be sitting at +10. Both of those places have that same distance. So we're trying to find out what x is to make it happen. And then we're just going to solve each of those. Add 7, -3, divide by 2. Get a fraction answer there, and that's quite okay. Same work over here. Divide by 2. Get another fraction answer, 17/2. there we have two answers. If you plug them back into the original problem, they both work. And so again, it's equations, so we can check all our answers and know whether or not we're doing it right before we turn it in. So there shouldn't be any. Let's do this one. 6 minus 4x inside of absolute value plus 2 is equal to 16. So start kind of adding a little bit to it here. So what's the difference in example D and examples B and C that we did? It's got that plus 2 after it, right? So if we can get the absolute value by itself, it makes it look like the other ones we did, right? So how do I get the absolute value by itself? Yeah, just get rid of that 2 by subtraction. That's a good start. So we get absolute value of 6 minus 4x is equal to 14. And absolute value is equal to a positive number, so this one's good to go. So we set that up and solve it. 6 minus 4x is equal to negative 14. 6 minus 4x is equal to positive 14. It doesn't matter if you put the negative on the left and the positive on the right. It doesn't matter what order you do that in. We're just getting 2 answers here. So what's our first step on this one? Subtract 6. Good job. Negative 4x is equal to negative 20. Divide by negative 4. Positive 5. Same thing over here. Negative 4x is equal to 8 this time. And then divide by negative 4. Get a negative 2 as an answer. Again, we can take both of those solutions, plug them back into the original, and we should be able to tell if that's the correct solutions or not. And it is for this. Those are the right answers. Okay. Let's do this one. 11, absolute value, 2x plus 8, minus 66 equals, make up some new numbers here, 176. So bigger numbers. What would be our first step in doing this one? Yeah, get that 66 over there out of the way. 11, absolute value, 2x plus 8. 176 and 66, 2, here you go. It's 13, 14. 242. Is that right? And then next step. Divide by 11. Why not distribute that 11? I'm trying to get rid of it. That's a good reason. Also, it's coming, if you distribute it out into the absolute value, do you distribute a positive 11 or do you distribute a negative 11? We don't know which one it was to begin with. So never distribute across an absolute value sign. Okay? As always a rule, don't distribute across an absolute value sign because you don't know if that was a positive or a negative 11 before it came out. And that would change what's on the inside. If it was negative, definitely would change everything. So dividing by the 11 is the right move there. There we get absolute value of 2x plus 8 is equal to what? 22. All right. Here's the checking step. You see, okay, is absolute value equal to a positive number? If it is, that means you got answers. If it's not, if it's equal to negative numbers, then you don't have any solutions. So this one does have solutions because it is equal to a positive. So we're going to set up 2x plus 8 equals negative 22. 2x plus 8 equals positive 22. And solve both of those. Subtract 8. 2x is equal to negative 30. Divide by 2. The first answer is going to be x is negative 15. Good to go. Go to the other side. 16. Nope. 14. Sorry. And then divide by 2. 7. We get 7 and negative 15 as solutions to that one. Again, at this step right here, when you get the absolute value by itself, that's where you check to see if you have no solution. If it's equal to a negative, you don't have to work it any further. That's no solution, automatic. Don't do anything. If it's equal to a positive or 0, then you got to work it and go from there. All right. Example F. 2/3. Absolute value, x minus 5 plus 4 is equal to 7. Record time. It's a first move. Yeah, minus 4. 2/3. Absolute value of x minus 5 is equal to 3. Next move. Divide by 2/3, which is the same thing as multiplying by 3/2. Absolute value of x minus 5 is equal to 9/2, which is a fraction, but it is a positive number. So that makes it okay. So we do have answers to this one. So we're going to set up two equations. X minus 5 equals negative 9/2. X minus 5 equals positive 9/2. And then add 5, which is the same thing as 10/2. So that's going to be 1/2. And that's going to be 19/2. And again, leave those as fraction answers. Don't change them to decimals. Don't change them to mixed numbers. Leave them as those improper fractions, but reduced as far as they'll go. Questions so far? All right. Absolute value of x plus 17 plus 5 is equal to 2. Our first step. Subtract 5. Absolute value of x plus 17 is equal to what? -3. What do we know about that? That's a no solution. Because absolute value is a distance and cannot be negative. It has to be equal to a positive value. No solution, or a little circle with a slash through it. The empty set's what that means. Same, there's just mean the same things. Okay, so no solution or the little circle with a slash through it mean the same thing. So be careful of those. They come up from time to time, and sometimes they're kind of sneaky, and they'll throw a problem like this in there. Let's make that a 4 instead of a 6. Change that, sorry. Make the numbers work better. What's the first move? Subtract 10. It's going to give me -6 over there. And that's no solution, right? I got to finish all. I got to get the absolute value completely by itself before I can decide. So I got to get rid of this -3 before I do that. And then there we get absolute value of x plus 6 is equal to +2, which does have solutions. So they'll try to throw some stuff in there, some little curveballs, change-ups, and try to get you looking at it and trying to quit early. So set them up. X plus 6 is equal to -2. X plus 6 is equal to +2. -8. And -4. Both negative solutions, but they work in the original problem if you go back and plug them in. Pretty easy thing there. All right. So that's equations with absolute value. Okay. Equations with absolute value are pretty straightforward. If it's equal to a positive, once you get absolute value by itself, set it up and solve it. You should get 2 different numbers as answers. That's pretty much what's going to happen. Let's look at inequalities, which is the same section, but it's inequalities with absolute value. So with absolute value, inequalities, these they create compound inequalities. And the reason that they do that is when you have an absolute value, if it's less than a number, and we think about what absolute value is. Absolute value is distance away from 0. Okay, so if we think about the number line, so I'm just going to put 0 right there in the middle, and we pick a number that absolute value could be less than. So like absolute value that's less than 5. So if I went over to my number line, where could absolute value be 5? Up here at +5 or -5. If the stuff inside the absolute value is less than that number, less than 5, then where can it be? Towards 0 or away from 0? Towards 0. So a less than, if you remember absolute compound inequalities with absolute value, less than, your answers are going to be in between there. And those should be open circles, not filled in, because I didn't have an equal to mark on that. So that's an and problem. So a less than is and. If it's absolute value greater than a number, so taking the same idea, and it's greater than 5, what kind of numbers have an absolute value bigger than 5? Numbers that are outside of 5, like 6 and 7 and all that. And over here, outside of -5, so that's -7, -8. So those graphs do this. And those are or problems. And problems come from less thans, or problems come from greater thans. The way that I like to help you remember this is the saying called land of Gore. My wife she teaches math too. High school, we play tomorrow. We're probably not going. But land of Gore, she has a whole poem that goes with this. I don't know it all, so I won't even attempt it. But this little saying right here, land of Gore, less than is and, greater than is or. If you remember that, that'll help you when you get into this section with the absolute value inequalities. Absolute value is always going to be on the left every single time. When you look at that problem, absolute value is going to be on the left side. You look at the inequality symbol, If it's a less than symbol, so that's less than or equal to, greater than or equal to. Either, if it's less than, it's an and problem. If it's a greater than, it's an or problem. Every single time. Always. Okay? So let's set up and do a few of these. And we've got to decide if it's an and or an or problem before we set up the problem and work it out. So, and then we're going to write the solutions in the inequality form. We're going to graph them on a number line, and we're going to write it in interval notation. So a lot of stuff going on with the answers here. I think we're on example I. So absolute value of 2x minus 5 is greater than 7. Is the absolute value by itself? Yes. So we got to make sure of that first. Then we look at it, make sure it's on the left-hand side, and then decide, is this an and or an or problem? What kind of symbol is that? Greater than, so this is an or problem. So we're going to set it up, drop the absolute value marks. What did I write on that? 7 or 2x minus 5. Flip the symbol, change the sign. One of them is exactly the same. Just take away the absolute value marks. The other one, flip the symbol, change the sign. Solve each of those separately. Just like we did with the equations. 2x is greater than 12. Divide by 2. X is greater than 6. Or, over here and solve this one. Plus 5. 2x is less than negative 2. Divide by 2. X is less than, I'm going to write a little closer there. X is less than negative 1. So there's our inequality answer there. X is either greater than 6 or less than negative 1. Let's put that on a number line. Okay. Draw yourself a number line. Make sure both of your numbers will fit on there. Now, when I do the number lines, I'm going to do them with interval notation marks. Instead of open circle filled in circle, I'm going to use parentheses and brackets. Just because I think it helps bridge that gap. Okay, so on the 6, it's x is greater than 6. So that's going to be a parenthesis opening up and to the right. Because those are the numbers that are greater than 6, 7, 8, 9, this direction. When I go to the negative 1, it's going to be a parenthesis opening up to the left and arrow going to the left. And that shows me all the numbers that are less than negative 1, negative 2, negative 3, all the way down. The interval notation for that. What's way out here at the end of this arrow? Negative infinity. And then we're stopping at negative 1, but we're not including it. So we're going to put a parenthesis, union. Then what's the next number we start with? 6. And where's that arrow going toward the right? Up to positive infinity. So there's our interval notation for that. So we get inequality notation, number line, and interval. All three of those ways of writing the solutions to do that. Okay. Absolute value of 2 minus 5x is greater than or equal to 4. Is the absolute value by itself? it on the left? Yes. So it's ready to decide and or. It's a greater than symbol, so it's an or problem. So we're just going to set up two inequalities. 2 minus 5x greater than or equal to 4, or 2 minus 5x, flip, change. Solve each of those. Right, so subtract 2, negative 5x is greater than or equal to 2. And then I'm going to divide by negative 5. What happens when you divide by a negative in inequality world? Flip your symbol. So that's going to be x is less than or equal to negative 2/5. Or, and then we're going to go do the other one. Subtract 2, negative 5x is less than or equal to negative 6. Divide by negative 5. Again, flip the symbol. So that's going to be x is greater than or equal to positive 6/5. Okay. The good news is both of those fractions have the same denominator, so that makes the number line super easy to draw. So when I go to put that on the number line, I'm just going to change the numerators. We'll have to make it longer because I didn't draw long enough. That's long enough. That's nice. When the denominators are the same, you can do it that way. I'm not too picky on your drawing of your number lines. Be able to recognize the correct one on the canvas thing, which it'll draw it for you. There. All right. So at the negative 2/5, we're going to put a bracket or a parenthesis. Bracket, opening to the left, and go in that direction. At the 6/5 bracket, going to the right. What's the interval notation? Negative infinity to where? Negative 2/5. Bracket on the negative 2/5. Union. Where do I start back up? Bracket. 6/5 to infinity. There's all three of our types of answers for that one. Questions about those so far? Had a couple of or problems. You can guess what's next. Say, what letter we're on here? Lost it. Okay. Let's do negative 2, absolute value of 3x minus 8. Close the absolute values. Plus 1 is greater than or equal to negative 9. Step it up a little bit here. This kind of gets us into a little bit more complicated problem and maybe an and problem. Right now it's a greater than symbol, so I'm thinking or problem. But what do we got to do first before we can even decide? And get the absolute value by itself. So let's get that done first. So I'm going to subtract 1 negative 2, absolute value of 3x minus 8 greater than or equal to negative 10. And then divide by the negative 2. And when I divide or multiply by a negative with absolute value, or with inequalities, the absolute value of 3x minus 8 flips the symbol, change the sign. So we get less than or equal to positive 5. So this becomes a what kind of problem? That's an and problem. You may have been taught to do and problems as two separate ones with the word and in between them, and that works. I don't particularly do them that way. I like to do the sandwich, put them in a sandwich together. So we put a 3x minus 8. So we take the absolute value symbols off of it and just write the first inequality. Then I go down to the left-hand side and I put another less than or equal to symbol and put the negative 5 down there. That takes care of the flip and change to do it that way. And then you only have to work one problem. And you don't have to do any kind of extra graphing. So I'm going to solve this problem then. Plus 8. So if I add 8 in the middle, I got to add 8 on both ends. 3 less than or equal to 3x less than or equal to 13. And then divide by 3. One is less than or equal to x is less than or equal to 13 over 3, which is just a fraction. And the beautiful thing about this is that when you go to draw your number line, you don't have to put all those fractions there. 13 over 3. When you got a mix of a regular integer and then a fraction, I always just say estimate where 13 over 3 is. So 13 over 3 is estimated to be where? How much is it as a decimal? 4.3. So I need to go, I'm going to have 0, 1, 2, 3, 4. I'm just going to go ahead and go up to 6 because I had room. And then around the 1, I'm going to put a bracket. And around 4 and 1/3, which would be about right there, put a bracket right there. And then my answers are in the middle because it's an and problem. The interval notation is bracket 1, comma, 13 over 3, bracket. The equal to marks are the brackets. If it doesn't have equal to marks, they're going to be parentheses. If it has equal to marks, it's going to be brackets. On an and problem, they're always either going to all be parentheses or all be brackets on an and problem. An or problem, same way with absolute value. It is anyway. So, all right. One more really tough one to end the night with. Told you less than an hour. I'm breaking records tonight. I don't even know if that's the right letter. It isn't. I skipped a couple examples. That's how I'm getting them real quick. Some of them that were the same thing over and over. All right, so this one has two absolute values in it, but it's an equation. So let's say absolute value of 4x minus 3 equals absolute value of x plus 6. So double absolute value problem. This one's a tougher one to do. Now, the idea here is that you have absolute value, which always has to be equal to a what kind of number? Positive number. But because there's variables on both sides, that could definitely be lots of answers because you have two different places. Now, the way you want to do this is you want to set up and say, okay, I'm going to work the problem with the absolute value on the left first. So I'm going to say this is going to be 4x minus 3 is equal to x plus 6. and then 4x minus 3 is equal to the opposite. So it's, instead of saying if it had a 5 there, we would say positive 5 and then equal to negative 5. But because it has an x plus 6 over there, we're going to say negative parentheses x plus 6. Okay. So negate the whole side, which means change the sign of everybody. So over here, this is going to be negative x minus 6 is what's happening there. And those are the two equations that you're going to solve. So add 3, subtract x. 3x equals 9. Divide by 3. X is equal to 3. That's one of our possible answers. Same thing on the other side. We're going to add 3. And instead of subtracting x, we're going to add x this time. And x, that's going to give us 5x is equal to negative 3. We're going to divide by 5. Where this gets more complicated is that because there are x's on both sides of the problem, you have to check these to see if one of them might be what's called an extraneous solution, meaning it's extra, and that you could find it, but it doesn't work for the problem. So if I plug in a positive 3 into the original problem, that would be 4 times 3 is 12, minus 3 is 9. On the other side, 3 plus 6 is 9. So this one checks, it works. So that worked. I'm going to go and work the next one. I'm going to plug in negative 3 over 5. And I'm not so great with fractions without a little help here. So I'm going to say 4 parentheses negative 3 over 5 minus 3. And then that's in absolute value. So it ends up being positive 5.4. On the other side, I'm going to say negative 3 over 5 plus 6. That's in absolute value. Are those equal? If they're in absolute values. If they're both in absolute values, then they are equal. So both of those answers check. That won't always happen. Sometimes you will find two solutions and one of them will work, the other one won't. So especially when it's an equation that has variables on both sides, you need to set up and get your answers and then check them in the original problem. Sometimes all of them will work and you'll keep them all. Sometimes one of them won't work and you'll have to throw it out. Okay, so keep that in mind as you're working these problems, that could happen. So I always just stick with the left one being an absolute value and then negate the right-hand side one. You could do it the other way if you wanted to, but I don't see any need in that. All right. So problems that you could look at in your textbook if you wanted to practice up for the Canvas quizzes in R.2. There aren't a whole lot of problems in there because it was just part of the section. And then in 1.8, 1 through 67, any of those odds obviously would be a good idea. So it gives you a good shot at it.